Okay, this document links with the IB Higher Level Option 7 Statistics topic, and we're going to look at a binomial distribution, and we're going to start off with a binomial distribution with 20 trials with a probability of success of, let's say, 0.2. If we go to the next page, page 1.3, we see a dot plot of taking 20 values from that binomial distribution, and we can increase the number of samples if we wish, and we can start to see that the shape of the binomial distribution is indeed clustered down towards the lower end. So we are just taking single results and plotting them. Now, what we've actually got down here is we're plotting the sample mean, but when you've got a sample of size 1, that is effectively no further calculation. But if I now go for a sample of size 2, what it's effectively done, each of these dots represents a calculation from having done 2 values from a binomial distribution and working out the mean of them. If I go again to 3 or 4 or 5 or 6 or indeed all the way up to about 10, each of these dots is now representing 10 individual values from that original binomial parent distribution, and working out the mean of those 10 values and then plotting that mean. And the students can very quickly start to see that the data is clustering around, it looks to be around about 4. If we go back and look at the original parameters, we can look to see that the mean of this distribution, 20 times 0.2 is around about, it is 4, and therefore if we increase the number of samples and increase the sample size, we can pretty much get all these sample means to be centered around the mean of the parent distribution from which the samples have come. Now, we started off with a distribution that had a slight shape to it, and the binomial has just been compressed and compressed further, and this is actually now looking as if it is a normal distribution. Not particularly convincing in this particular case, but we're leading into the central limit theorem. But we happen to start with a known distribution, which here was the binomial. We're done.